Our next speaker, Nathan Baggio, has been with Costco for 14 years, working through operations, buying, food safety, as well as managing investigations, root cause analysis, and corrective preventive action plans on Costco IT systems. Currently, he manages Costco's U.S. food safety vendor audit program, as well as their foreign supplier verification program and HACCP teams. Speaking on the importance of foreign material detection, please welcome Nathan Baggio.
Thank you, John. Really appreciate it. Good morning, good afternoon to everyone. Today we're going to be talking about foreign material controls. So yeah, let's get into it. So based on Sedgwick's 2023 Q2 report, foreign material came in as the third highest reason for recalls for FDA regulated items. But they actually came in second for number of impacted units. For USDA regulated items, it actually tied undeclared allergens with 4 recall events each. So foreign material is really important. We need to be mindful of it.
Nathan, apologize for interrupting. We're not seeing your presentation. Can you share that, or do you need our assistance with loading that?
Nope, I got it.
You're the best. Thank you.
Yeah. Thank you for letting me know that. Okay, now can you guys see it now?
Yes, we can. Thank you.
Perfect. Okay, so yeah, like I was saying, FDA recalls, foreign materials number 3 for reason. Units, it's number 2 for number of units impacted. USDA was tied with, USDA regulated items was tied for foreign material and undeclared allergens. Generally, when we were thinking about foreign material, you know, I think a lot of people default to glass, metal, wood. Pretty much anything can be foreign material if not handled properly. It can come in on anything, it can come off of anything. It can also be an issue after it leaves our control. So it is really important to document your foreign material controls effectively. That way, if an incident does occur and someone starts pointing a finger, you do have some documentation to fall back on. So foreign material programs are going to be, they're going to vary in terms of complexity and sophistication. Generally, a good foreign material program will have a mix of prevention, detection, and response. So prevention is going to be things like your supplier approval program, your GMPs, maintenance programs, anything to mitigate that foreign material actually getting into your system and the product stream. And then you're going to have the detection systems, which are going to be like X-ray, metal detection, physical barriers, so filters, screens, sieves, anything that's actually going to either remove the contaminated product from the product stream or remove the contaminant from the product stream. And then your response is going to be, what are you doing with that contaminated product? You know, how are you handling it? What type of investigation you're doing if incidents occur. The root cause analysis, the corrective actions and preventive actions are all going to be your response to identifying contaminants or contaminated product. So prevention, you should prioritize prevention over anything else, right? Detection is only going to be a backup, and that's what it should be. It's a fail-safe. Your prevention methods should take priority over anything else. You know, we do want to mitigate that foreign material from entering the product stream first. Detection is not going to be 100%. You know, you should not rely on that. So these preventive controls are very important and should be prioritized. So for the supplier approval program, you're going to want to evaluate suppliers and include a comprehensive assessment for foreign material risks and controls. Utilize a variety of methods, questionnaires, sampling, audits to understand their foreign material controls. And then whatever foreign material controls they have, consider including that in your specification. So if they're telling you they're running it through a metal detector, include in your specification, run through a metal detector or an X-ray. I suggest avoid relying solely on letters of guarantee, specifically because those aren't audited. I've never heard an auditor ever ask, how many letters of guarantee do you have out there? They always ask about specifications. What are you making to these specifications? That's what's going to be audited. So include those types of things in your specifications if they have those types of controls. And then you need to monitor and document. So monitor and document the quality through your receiving and QC processes. So at receipt, at use, you're checking the incoming materials, you're checking the integrity, you're checking the, do they meet specifications? If you are getting findings, you should be requesting corrective and preventive actions from your supplier. Build a scorecard for them and start, adding these findings to that scorecard, because then you'll be able to analyze over time and trend to reevaluate that supplier periodically and figure out, is this supplier someone I want to continue, or am I going to go somewhere else because I've consistently had issues with these guys? And then you're going to move on to the receiving process, which is your first line of defense against foreign material risks, from entering the product stream. So when you're at receiving, you're going to check, product name, materials match, looking for any damaged boxes, containers, pallets, making sure pallets haven't, punctured product. You should be implementing, QC sampling at a defined frequency, checking for the materials against specifications, including packaging materials, right? So if you're having packaging materials coming in, check it against the specification, make sure it's that same thickness that you ordered. Thinner materials have a tendency to rip, tear. Packaging material can be a source of foreign material, so it is important to be verifying those against specification as well. If possible, utilize metal detectors, X-rays for incoming goods. If you have existing units for a metal detector or an X-ray, and you can take a sample and run some product through there, periodically, that's not the worst idea to add to your QC sampling method, to hold that supplier to whatever specification you've written up and agreed to with them. And then document the findings, trend them, and adjust your sampling frequency if needed. Again, to hold that supplier to the specification that you agreed to, and over time you'll be able to reevaluate their performance and determine if you are going to stick with them or not. So building integrity is essential for preventing contamination, especially for older facilities. I know everybody would love a brand new facility built from the ground up, state-of-the-art materials. Not the reality for most folks. You're going to be working with existing structures, so you're going to have to focus on continuous maintenance and monitoring. Start with a comprehensive risk assessment and evaluation of your facility. Identify problematic areas, vulnerabilities, and then integrate those within your maintenance program. So building maintenance and equipment maintenance should be on a PM program, and set a frequency of how often you need to be maintaining it. That frequency is going to have to adjust, just like any other PM. You will have to adjust that over time as wear and tear, age accumulates on the facility, your equipment. Just to be mindful of it. It is going to be an ongoing thing. You're never going to be done and say, this is what my PM is going to be consistent throughout forever, right? You are going to have to adapt things to degrade and worsen over time. So monitoring, leverage routine inspections, right? So for your structural inspections, pest walks, GMPs, sanitation checks, all good opportunities to check the integrity of your building to make sure that you are preserving the physical condition and mitigating any risk. So equipment selection is another integral part of preventing foreign material. So when you're selecting equipment, whether it's new or newer to you, like refurbished equipment, you should involve maintenance, engineering, and the food safety teams to make sure that it's not only going to align with, the operational needs, but also safety, maintenance needs. And as, like I said, is going to apply to both new and refurbished equipment. Engage the equipment manufacturer, whether it's new or used. Reach out to them and understand, any design elements to the equipment. If they've had any concerns with that specific equipment, any feedback, ensure it meets hygienic design principles. Ask about any potential areas of concern, like metal to plastic contact points, any bolts, nuts, or labels that may be over product zones. Ask them about that, and then identify and eliminate, if possible, any product accumulation points. So ask them if they know of any of those, if they've gotten any feedback on that, saying, hey, there's an issue. Manufacturers will open up and say, yeah, yes, these are things we have seen. So it is good to engage them. And then, get the user manual, assess the suitability against the intended use within your process and your product. Look for cleaning recommendations, any practices, any chemicals, any do's or don'ts for that specific equipment. Look for a preventive maintenance schedule. Generally they'll have some type of schedule that you should upkeep to maintain that specific piece of equipment. And then, processing conditions and suitability. So, is it going to handle extreme cold? Is it going to operate well in wet processes, or is it not really suitable for those? To make sure that whatever your intended use is, whatever your environment is, this is the right equipment for you, and it's going to hold up against the conditions that you're throwing at it. Next, you want to compile a parts list and figure out the detectability of those parts. So compile a complete list of the removable parts, verify the material specifications, confirm if those are detectable or not, and then do a risk assessment for anything that's not detectable. If you can remove them and replace them with detectable parts, that is suggested, not always going to be the case, but that is something to consider. And then once you figure out what should be detectable, actually make sure that's detectable with your detection system. So run it through your metal detector, run it through your X-ray. Some components may be detectable in certain detection methods and not in others. So even if the user manual says it might be, or the manufacturer says, yeah, this is detectable, or you guys think it's detectable, verify that and document it, that yeah, these parts are actually going to be picked up if they ever fall off within our process. Some additional checks for refurbished equipment. Make sure it was refurbished properly. Look for any signs of damage, wear, stress points, and make sure that it's in the right condition before you bring it into your facility. So with equipment inspection, so should be performing equipment inspections, tool inspections at regular intervals. So for equipment, following that PM schedule, you want to get ahead of that, make sure that you're actually doing inspections regularly, following up with the PMs. Are those PMs effective is also something you're going to be looking for. So the real purpose of the inspection is to account for any tools, parts, identify any damage, excessive wear, stress points, accumulation points, any needs to repair or replace it. For equipment, check any moving parts, belts, rollers, look at transfer points, look at any welds look at any welds to see if they're holding up or if they're starting to dimple or flake off or something like that. Looking at all the nuts, bolts, clamps, and pins, so everything holding it all together, all those little parts that kind of hold that machine together, make sure that those are holding up. You're also going to want to check any hand tools. So any tools that your personnel are using, you want to have those on an inspection program as well to prevent any breakage, any excessive wear over time. Really customize the frequency of these checks to your specific use case. So for equipment or tools, the manufacturers may make recommendations for frequency of checks with the PMs, but it is going to be but you should be basing it on starting with that, and then as you go through and actually start using this equipment, basing that frequency on your specific use case, right? So if you're noticing equipment or tools are fragile, they're starting to degrade quicker, that might be some basis for escalating the frequency of inspections. Also, frequency based on how much you're producing between the inspections. And then, like I said, historical data. So maintenance notes, inspection notes, customizing that frequency to your specific use case is important. It's also important to effectively document those checks. So reference conditions, so you can reference conditions for future inspections, and then create a feedback to the frequency of checks, replacements, PMs, and to mitigate expanded recall situations. So if you're having checks periodically and they're well documented, you might be able to limit the scope of any incident that occurs because you have documented these things so well, and you're able to fall back on it, which is also part of the benefits of more frequent inspections. So limiting the scope of affected products, as well as enables for quicker reaction to incidents that may occur. So maintenance best practices to prevent foreign material control. So tool accountability and cleanliness is very important when it comes to maintenance. Just like anything else in the facility, you want to be able to account for any of the tools that they're handling, bring it out onto the production floor. They want to maintain the carts, the tools, any lifts they're using. Emphasize tool accountability with them. If you're doing any fabrication or grinding in the material shop, you want to make sure that none of that's exiting that shop. So use swarf mats. That's something I see fairly frequently, something I'll call on facilities. If I ever see them grinding in the material shop and they don't have a swarf mat, because that stuff has tendency to find its way into the production area. So trying to mitigate that from leaving the shop is important. And then generally, just making sure that anything that they're bringing out is clean. do random checks, catch them when they're exiting the shop, and do a random check on their tools, their clothing, the carts they're using, whatever it is, to make sure that things are clean and they're not bringing contaminants into your processing environment. Another part of maintenance should be replacement part accountability. So consider designating personnel for parts management, documenting parts allocation and usage. You do want to control the usage and limit the parts provided to personnel. They should only be taking out parts that are needed to complete their PM or the work that they're doing. You don't want to give them unlimited access to potentially mishandle or misuse some of those parts. And then you also want to verify that any parts that they are using are suitable according to the manufacturer's recommendations, the manufacturer's specs. Incorrect or incompatible parts can lead to equipment damage or failure, potentially causing incidents. Also, too, for fabricated parts or maintenance solutions, maintenance people are brilliant. They will find solutions for everything. Whether those solutions hold up is another story, or hold up for how long is another story. So if they are providing solutions, that aren't the manufacturer's original parts, make sure that you're approving those and closely monitor those, right? For your preventative maintenance, you do want to have a written preempt schedule with well-defined frequency. Base that on the manufacturer's documentation, their recommendations, but then adjust that PM frequency to the equipment age and what you're seeing in terms of wear and tear. Use the maintenance notes, inspection notes as a feedback loop for that, to make sure that you're staying ahead of that PM schedule as that equipment ages. You also do want to track the PMs and make sure that those are being completed on time. There's a lot of systems out there that help do this. Making sure that completion rate is up there is important, so you're not missing PMs and staying on top of them to mitigate any emergency breakdowns or emergency maintenance requirements. If you do have, catastrophic failures, emergency maintenance situations, if breakage occurs, make sure that any product nearby that is on the processing line is held and evaluated. Account for any parts or tools that may have broken or need to be brought in, brought out. Again, tool and parts accountability, doing check-in, check-out is a good strategy for all of this. And then once you do all those maintenance, once you do the emergency maintenance, once you finish up with emergency maintenance or any maintenance, make sure you're doing a post-maintenance inspection, checking, verifying cleanliness, making sure all the parts and tools are accounted for, and not releasing that piece of equipment until QA has been able to evaluate it and been able to successfully document that it was done, it is clean, and we're good to go. So sharps control, make sure that anything you're using is fit for purpose. Use suitable tools for specific tasks. Inappropriate size or shape of knives may lead to increased breakage. If it's not suitable, it can increase the risk of damage to equipment or the tool itself breaking, right? Make sure that any knives, needles, blades, blades or needles are correctly installed and you have them on a replacement schedule. You're doing inspections. The correct installation is to reduce any breakage. Anything that's kind of skewed or off kilter puts a little bit more stress on the equipment and has a higher propensity to break. Replace any bent items promptly. Make sure you're sharpening regularly. Base that on any manufacturer's recommendations and then also the historical data that you have. Sharp tools break less often because less pressure is needed when using them. Should be replacing tools and parts, so needles, blades, knives, routinely, and then taking that adaptive approach as well with different sharp objects. So if something's wearing out quicker, you guys are seeing that you're having breakages more frequently, you may need to inspect or replace that equipment or those tools more frequently than you originally thought. So be aware of that. Make sure that you're documenting it. The reconciliation part of it, you want to track the total number of tools or parts that are either installed on the equipment or out in the production for use. Again, limit the number of tools that the personnel can take out, limited to only what they need to get the job done. If something is breaking, they need to dispose of it properly. You need to document that you disposed of it properly, and then doing routine inspections for wear or damage for those sharp objects. Ideally, each shift, again, to limit the scope of affected product if you do have a breakage or you do identify some damage for some of those sharp objects. And then record your inspections, replacements, and disposals to reference for future investigations or potential incidents that may have occurred. So personnel and visitor practices, stick with the standard GMPs for sure. I think everybody's going to be have those in place, but then tailor additional GMPs to your specific needs. Whatever your specific use case is, whatever your process is, your production environment, there's going to be different risks associated with it. As you go on, you may see things happening that need to be added to your GMPs, your personnel policies to mitigate any risk. So make sure that you're staying aware of those, keeping an eye out, using those GMP inspections as a feedback to your policy, your program to continuously improve it. And then also remain aware of any of the tools and PPE that are being used by personnel. So hair nets, gloves, smocks should be, rip resistant, tear resistant, shed resistant. Think about using any, foreign material detectable detectable materials for some of those. So you can get hair nets, gloves that are foreign material, that are material detectable or metal detectable. So consider doing those. Proper handling of PPE is important. So making sure that you guys are disposing of PPE properly. The picture here is actually something from one of our stores, one of our baked goods. Has a piece of glove in it. So making sure that this PPE is not becoming a foreign material concern or hazard is important. So stay aware of that. Making sure that they're only taking out what's necessary to get the job done, not taking out multiple hairnets, multiple pairs of gloves in the pockets or whatnot. Take single use. If it's rips or breaks, let you know about it and dispose of it, and then go get a new pair. For visitor policies, you can either integrate with standard GMP policy or standalone based on your risk assessment. Whatever you do, maintain strict GMPs with visitors. Make them aware beforehand, provide them the policy, hold them to that policy. I don't care if it's a Costco buyer, me, an auditor, whatever your GMP policy is, make sure your visitors are following that and just hold them accountable to it. Same goes for third-party contractors. Some third-party contractors are going to have a little bit more training than some, like buyers or something like that. So if you're having like pest control or Ecolab or something, like some sanitation company come in that has GMP training, assess the risk, but also make them aware of your policy and procedures and make sure that they know that they need to follow this. So any tools they're bringing in, any PPE they're supposed to be using, make sure they're aware of that and you're providing that policy and holding them to it. Best practice is to accompany visitors. Based on the risk assessment, some of the contractors may not need accompaniment, like pest control. If he's walking around your facility, don't necessarily need to accompany him every time. But the good policy is to accompany visitors whenever they're in your facility. So glass and brittle plastics. For material selection, use shatterproof, use shrouds. Think about getting metal detectable materials. There are plastics with embedded, material that makes it metal detectable. And then also protect lines, exposed lines whenever you have glass or brittle plastic above them. You do want to create a register for glass and brittle plastics. So either have a log or a map. For Costco suppliers, we do require a map. Doesn't need to be super, detailed, just a schematic of your floor plan, and then just use like little colored arrows or whatever it is to identify where those spots are that you need to be checking for your glass and brittle plastic inspection program. Also with the register, it can be beneficial to understand the composition of the material within your facility. So what type of glass you have. We've run into a number of incidents where, the glass actually came from one of our customers' kitchens rather than the processing facility that actually made the product. And the only reason we knew that was because the processing facility got the material back, sent it off for testing, and knew the material composition of the glass in their facility, and was able to say conclusively, this didn't come from us, right? So it can be good to know that if you have the capabilities and the resources to do that. For the inspection program, do set up an inspection program based on the risk, setting your own schedule. Consider the product proximity and risk when you're figuring out the frequency of the inspection. So maybe your dry storage where everything's packaged, whatnot, doesn't need to be walked as frequently as your production process where you have exposed product. So basing that frequency on the risk to the product is important. And then also adapting it as with the other programs, right? So whatever your specific use case is, you're adapting over time, evolving, understanding, if you're seeing breakages, if you're seeing problems in certain areas, maybe you need to increase the frequency of inspections, and then effectively document that, and then use that as a feedback loop. So whatever you're documenting, be able to reference back to. When you do encounter breakages, best practice, quarantine the affected areas and the products, have designated tools to clean up glass or brittle plastics, have designated color, designated tools to clean this type of material up, because you don't want it to be spread over the rest of your facility if there's little small shards or fragments. Also avoid using any methods that may exacerbate the problem. So don't be spraying it with water jet, air jet, because that's just going to blow things around or create more fragments. And then after you clean up the area, check the personnel, have their change out smocks, check their footwear, hair nets, anything where that may have been affected. Make sure that you're checking those, having those changed out, and then figuring out what the disposition of that potentially affected product was. So if something broke while product was running, it was nearby, what are you going to do about it? Figuring out what you're going to do with that product. Sometimes you're just going to have to throw it away because you really can't definitively say, yes, this was safe or protected, or no. Sometimes that's not always the case. So figuring out what you're going to do with that when breakages occur is important. For sanitation, so for the sanitation and mitigating foreign material, having a comprehensive understanding of the equipment and components is important. So during those transition points, what parts are removable and potentially sensitive. So anything that's going to be coming off, like belts, gaskets, pins, bolts, anything that that may be removable from the equipment that you're actually going to be cleaning, have some type of equipment parts checklist put together so you can verify that we took all of these pieces off and then we put them all back on after sanitation. And then that's also going to help you verify the integrity of those parts. So if any of them are sensitive, brittle, it's good to know and have verification of those before and after sanitation to make sure that nothing's broken, nothing's missing. Do exercise caution with some of those sensitive components. So cleaning chemicals can accelerate degradation of some pieces of equipment, some components of equipment. So be mindful of it. Use temporary measures if possible, right? So get a plastic tarp or whatever it is to cover up some of those sensitive components. Could be a good practice. And then maintain integrity and inventory of your cleaning tools. So inspect inventory cleaning tools, use tools that are fit for purpose, hygienic, not prone to shedding. Those green scrubbies, you kind of get little fibers that are coming off of it. Bristle brushes, make sure that those are well maintained. Like I said, chemicals can be pretty harsh to some of this equipment and can accelerate degradation. So maintaining accountability and an inspection program for those tools is important. And then also maintain accountability for PPE. So if sanitation personnel are using reusable PPE, make sure that you have some type of accountability program for that. Your check in, check out. If they're using single use, make sure that you're training them effectively on how to handle that PPE. You don't want them taking it off and not disposing of it properly. So proper handling of the PPE is important to mitigate any foreign material control hazards. During pre-op inspections, you're verifying sanitation, verify the parts, the tools, and the integrity of the equipment. It is a good opportunity to check the condition of your equipment. It's all clean. It's not you're having an unobstructed view of whatever it is, whatever piece of equipment you're looking at. So good chance to check and verify the integrity at pre-op. So your foreign material training program, provide a comprehensive training to your employees. Make sure that you're defining foreign material risks in general, and then also within their specific areas. Explain the consequences to them. Describe any prevention measures, hygiene, proper use of tools, equipment or PPE, um, things that they need to be aware of, making it job specific or facility specific, whatever your use case is. So train them to detect the type of foreign materials, and then encourage them to report, and then provide a method of reporting for the foreign material. So giving them a mechanism to actually communicate that to you effectively. Then provide ongoing training. So use a variety of training methods, lectures, demonstrations, hands-on exercises, make the training interactive and engaging, use real-world examples, lessons learned, incidents that occurred, factor that into your training program, provide opportunities for questions, practicing skills, and then evaluate the effectiveness and improve. Your frequency should be established, at least annually, but then as needed, again, adaptive, figuring out what is needed to mitigate some of the issues that you're seeing in your facility. Adjusting that frequency is important. Food safety culture is huge with anything in the food safety system. You need to show leadership commitment for foreign material controls. So implementing the controls, providing the necessary resources and investment to mitigate any problems with foreign material, holding the employees accountable, holding yourself accountable for following those programs. You really should be leading by example. If management is not following the rules, it is going to send the message to employees, these rules don't matter. They will pick up on that. So also work on employee engagement, right? Train the employees on how to identify, remove foreign materials from food products, encourage them to report anything, and then praise them for any findings that they report to you, right? You want to promote that that culture, that behavior, to make sure that these guys are being your eyes on the ground to spot these types of things. Creating that open communication. So creating culture of openness and transparency around food safety issues. Employees should feel safe, feel comfortable raising concerns about foreign materials, and they should be confident that if they are reporting things, things are going to get done about it. So having that documented process to take those reports and getting those implemented in a timely manner is going to be important to building that culture. It is going to kind of keep that going with the employees, making them feel like they are being heard, that their contribution matters. And that's going to, overall improve your continuous improvement process within your facility. So also continuously evaluate your foreign material control programs and make improvements as needed. This can be done by reviewing incident reports, conducting audits, benchmarking yourself against yourself or other organizations, and then documenting the findings and corrective actions. The food safety culture requirement within SQF or other GFSI standards is really powerful. It takes the responsibility off of QA alone and puts it on everybody in the facility. It mandates that it's not one person's job. It's all the departments, all the employees. So if you're finding deficiencies within your programs, foreign material specifically, maintenance or receiving production guys, you're identifying issues, mark those issues down and escalate them, right? Because the food safety culture says, these need to be addressed. It's not just the QA person's responsibility to manage this. It is the senior management and everybody in the facility that is responsible for this. So food defense, obviously have a comprehensive food defensive plan, integrate with existing programs, tool parts accountability, receiving sanitation, have check-in, check-out procedures to help safeguard against deliberate foreign material contamination events. Have access and opportunity control. So limit the personal items that employees are able to bring out. Have supervision in isolated areas, do random walkthroughs, have segregation of employees. So having employees working in specific areas and only working in those specific areas, and then training the employees to spot anybody that's out of place. So tool and parts accountability is going to be big with this because you're going to minimize the availability of the tools, right? They should only be bringing out tools that are needed to do the job. They don't need 3 or 4 wrenches if one will do the job. So minimizing the availability and having that accountability system in place. So at the end of the shift, you are able to verify that nothing is missing, nothing is left behind. So for pest control, inspect regularly, have that frequency defined. If you're seeing increased pest activity, you may need to increase it, talk to your PCO, work with them, fix any issues that they notice, you notice, sealing cracks, holes, any ingress points, maintain your environment, right? So making sure that you're cleaning up, making sure that things are tidy, things are accessible, and then identifying and treating pest issues that you may identify through your inspections. Monitor your facility on an ongoing basis, and then continue to have those regular inspections, responding promptly to whatever observations the PCO is calling out, you're calling out, and then also train your employees to spot pest activity as well and understand what attracts pests, what the risks are, because they can be foreign material as well as spreading disease. So detection methods are going to be, there's going to be a variety of types of detection methods. Metal detector, X-ray, physical barriers. Physical barriers are actually removal methods, but for detection methods or detection devices, like I said, there's a variety of types. It's not going to be a one-size-fits-all solution. Each method is going to have its own strengths and weaknesses. It is going to be application dependent. Depends on a number of factors such as type of foreign material that's being detected, size and shape of the product, production volume, production speeds. There is no perfect system. Also, don't rely solely on detection, right? Your prevention method should be mitigating foreign material from entering the product stream. These detection methods are only a backup. They're only your fail-safe. They are important. They are part of a good foreign material control program, but your priority should be on the prevention methods to mitigate any foreign material from actually entering the production process. Consider multiple systems to create a multi-hurdle approach, right? So if you already have a metal detector and you're considering getting an X-ray, it's not the worst idea to maintain a metal detector and an X-ray. We do that in our facilities because each one will have its strengths and its weaknesses, and combining those can make it, create an even more effective detection method in the long term by creating redundancy, again, strengths and weaknesses, making sure or having them cover each other. Evaluate technology periodically, right? So there are going to be developments over time. Metal detectors improved, X-rays improved, vision systems are improving. There are developments there. So depending on your application, depending on your product process, do look into those periodically to see if there's a better solution out there that may provide some additional benefits long term. with detection systems, you're going to have to look at rejection mechanisms. There are a variety of types, multiple considerations like speed of the conveyor belt, size and shape of the product, weight of the product, viscosity. Um, it is going to be application dependent, your specific use case, whatever is going to work out best for your product and process. Whatever it is you choose, to make sure that it's properly set up and maintained. Foreign material detection is only as good as its rejection mechanism. If it's not rejecting the product once it's detected, it's kind of pointless. So make sure it's properly installed and functions effectively. Verify those rejection capabilities during your metal detector checks, your X-ray checks. Make sure that it's kicking off that product as it should. So to verify that your rejection mechanism is actually functioning. Detection placement, there also is going to be a variety of factors with this. So type of foreign material that you're trying to detect, product properties, the objective of the detection method, any spatial constraints you have, and the cost of the system itself. Choose based on your process and intended result of it. Like I said, multiple units may be justified. Might be true if its product is processed multiple stages, or if there are multiple potential sources of foreign material. So consider multiple units if those are applicable, whatever your intended use of the detection system is. That is a consideration to have. So annual validation of the detection systems, the reject mechanism should be documented, right? So have that outside contractor come in, validate that the detection system is working, the rejection system is working, and then have your verification frequencies set, based on a number of factors. So consider product volume, customer regulatory requirements. We require every 2 hours metal detector checks, start, end of shift, any breaks, any downtime. But figure out the frequency that's going to work best for you, as well as meeting any customer regulatory requirements. Verification check failures. So if you're getting check failures, any product that's run through that's been run through that metal detector or X-ray since the last good check needs to be held back. Your options, if you do encounter those, rerun through detection or an alternative method. You could be visually inspecting it, breaking it down, whatever it is, but assess the practicality of reinspecting the impacted quantity to figure out what your next steps are there. And then do a continuous reassessment, regularly review the frequencies, adjust your verification schedule if needed, if you're seeing issues, or you're increasing production volume. Make sure you're addressing those and reassessing, and then maintaining any records of failures to make informed decisions like that. So the response portion of it, effectively handling any non-conforming products. So physical separation. If you're getting rejects, if you have non-conforming product, immediately separating that rejected product from the product stream. You can use a lock container. That's what we prefer. If it's possible, you can divert through separate conveyor, or have a trained employee handle it. So we're actually moving it and placing it into a QA hold area. You got to determine what the fate of the product is once you get rejects. So if foreign material is detected and you break it down and you actually find foreign material in your product, you need to discard the product, remove the foreign material and release it if possible. You can remove the foreign material and rework it if possible. If you're not finding the foreign material after you're getting your rejects, there is a possibility of a false positive. inspect the product again, adjust or temporarily remove the detection system, and figure out what your alternative means for protection is going to be if those are being removed. Any non-conforming product, maintain a controlled access to it. So limit access to non-conforming products to trained technicians only. Whoever that is going to be QC staff, QA. Make sure that regular employees, regular production employees don't have the opportunity to place that back into the product stream. Sometimes that happens on accident. From a food defense perspective, that can be deliberate. So maintaining controlled access of that non-conforming product is important. For those QA hold areas, use clear and conspicuous signage. You can mark rejected products or designate specific holding areas using, in your steel, preferably away from the finished material or finished goods storage, so it's not mistakenly pulled and placed back into distribution. And then also maintain comprehensive documentation of non-conforming products. So what you did with it, what your investigation was, what your disposition of that product was. So your investigations should be timely, comprehensive, systematic, and documented. Collect all the information that you need. So type of foreign material, location where it was found, time and date it was found, interview the people involved, operators, quality control inspectors, packaging staff, gathering information about the incident, inspect the production line and equipment, do a hands-on investigation of the entire production process, looking for where this foreign material could have come from, visually inspect the equipment, materials for any signs of damage, unusual sounds, sitting out there and listening. If you're hearing any rattling, that could be a sign that, there is damage with the equipment, and you might need to be looking into that specific equipment. Analyze any raw materials and packaging materials. So examining the records related to the raw materials, ingredients, packaging, or other materials. Contact the supplier if anything points to an ingredient issue, right? Understand what their controls are through your supplier approval program, and then contacting them and requesting corrective or preventive action if you determine that the ingredient is the source of this foreign material. Perform a record review for all relevant records, so maintenance, operations, safety, sanitation. This can help identify a potential source. Conduct laboratory tests to identify foreign material, so actual composition of the foreign material. If you're able to retrieve that, like if it's coming back from a complaint from a customer, try to get that material back. And if you can, send it out to testing to determine what it is, if it's not apparent. And then develop and implement any corrective actions. For root cause analysis, so this is essential for any effective preventive actions, right? You really can't implement effective preventive actions without understanding what the root cause of the issue is. Choosing a root cause method is going to be dependent on a number of factors: the complexity of the problem, the availability of data, the involvement of stakeholders, the skills and experience of the people conducting the analysis. No single method is perfect, and it is often helpful to use a combination of methods. Challenges are going to occur. You may not always be able to identify the true root cause. That's okay. You want to do your due diligence and document that you've gone through the investigation and you tried to do everything you could to identify where this issue came from, what the cause was. But if there's missing critical information, or the form materials not matching any materials within the operation, any of your equipment, document your findings, and make sure you keep that on record in case any potential issues occur, like recur. You have similar issues that come up or similar complaints, or you identify other issues within your facility that might shed light on where that form ratio might have come from at a later time. Always document and learn from any these analyses, right? So even if you can't figure out what the root cause is, it's crucial to document the investigation thoroughly. Use these reference, and as I said, in case additional information becomes available or similar incidents occur. Incidents without a clear root cause may still yield valuable learnings. And even if you don't understand the true root cause of a specific incident, you can implement some corrective actions and preventative actions based on what you learn from that analysis. And that is it. Thank you.